Okay, here's a very brief video about constructing an index. An index is simply a variable that summarizes observations from a number of different indicator variables. So in our case, we have several banks of questions that are indicating people's responses to a set of related items. So one of those is people's use of software for analysis, data analysis and programming in prior circumstances. And so that's what we're looking at here in the pink highlighting here, variables 35 through 46. And what I did is I simply added a column to the left of those and made a new variable name. I just made it variable 135 um, out of kind of an arbitrary sense of making it 100 more than the starting variable from that set. And what I did is I just set that variable equal to the sum of the range from variable 35 through 46, which are all the questions that ask about people's prior use and kind of these Likert scale-wise time periods from no experience to some to, I forget, a certain number of months. Anyways, I could go back and look at it exactly, but that's not as important here as just the notion that all it's doing is just summing up all of those observations. So you can see a couple things. We have quite a range. We go from no experience or one or kind of low amounts of experience for many people to kind of relatively high levels of experience for some of the other folks in the class. So there's a wide range there. You can also see that a couple of our problematic cases have a bunch of missing values here, and so you might make the argument that maybe we should exclude those because so many of their values have been substituted from the median value. But that being said, we can look at the implications of those in a little bit. And I made a second index over here, which is based on people's confidence. And this has a bunch of related questions. So data recoding, confidence, blah, blah, blah. And we can see this also has a wide range from going from about 0 to 50. And in terms of adding up people's confidence in the different areas of tasks for this course. So that being said, I made those, and then what I did is I copied and pasted the values from those onto a new sheet and put them next to each other. And I put some thought into what I thought might be possibly a cause of the other. I didn't think confidence would cause people's software, but software exposure might cause people's confidence, although probably both of these are caused by something we might term training or experience that is prior to both kind of causally. But regardless, then I just made a scatter plot based on those, and I changed the scatter plot settings based on advice from a data analysis book to make them hollow. And then I made these two triangular ones. These are the two problematic cases over here with, excuse me, over here with lots of missing values in the area of software experience, but not lots of missing values in the areas of confidence. So our confidence estimate is good. Our software experience estimate might have some error around that. So in that sense, you could think of these representing a range that goes back and forth to either side for what the true value might be. But we can see that they fall along kind of this main sort of line of there being a positive association. So as what we mean by that, as software experience increases, confidence tends to increase. There are a couple outliers over here that are very confident but with not a lot of software experience. And there's a person down here who has not so much confidence but has more experience than many of the others in the class. So we can guess that actually maybe if there is some sort of relationship here, that maybe both these groups over here on this side and down here on the bottom might actually be underestimating or overestimating something about their abilities or the challenge in the course. So anyways, we can talk about the roles of missing values in construction of indices in the future in class, but I just wanted to kind of show how that's made. It's very straightforward.